Alright, so in this video we're going to take a look at functions, function notation, a little bit of stuff on our what we call our difference quotient. One of the important things we have in calculus is the domain, and maybe back in Algebra 2 remember that domain are your x values. There are two things we're looking for when we talk about the domain of a function. Number one, we never want to have division by zero. Division by zero is undefined. In this class we don't look at that at all. And then the second thing that we don't want to have is negatives under a square root or an even root, and what happens there is those are imaginary numbers, and we don't want to have any imaginary numbers. We don't look at imaginary numbers in this class. If we take a look at an example of this, let's try to find the domain of, say, this function. A lot of times in our free response questions they'll ask you for domain of a function way back in, or when you're doing the exam later on. Say we have the square root of x squared minus 4 over 1 minus x. We know that x cannot be 1. It can't be 1 because that would be division by 0. And then the other thing that we're concerned about is that x squared minus 4 has to be greater than or equal to 0. Now to solve that inequality, we want to go back to what we did in our previous couple of examples, our previous couple of videos, and we're going to factor it. So we're going to write it as x minus 2 times x plus 2 is greater than or equal to 0. Draw your number line. So we go x minus 2, and then we go x plus 2. Number line, the top equation has a 0 at 2. The bottom equation has a 0 at negative 2. Negative on the left, positive on the right. Negative on the left, positive on the right. If you put that together, the two things together, you find that the domain of this function is less than negative 2, because that's where their product is going to be greater than 0. So negative infinity to negative 2. We can include negative 2 because you can take the square root of 0. Union with 2 to infinity. And really that 1 that never came into play because it's not in the domain that's underneath the square root. Another thing that we do with function notation is we take a look at, let's say we have an equation like f of x equals 2x plus 5. And I'm going to develop what we call the difference quotient. And the difference quotient is an incredibly important concept. This is what the derivative is going to be based on, where our whole first semester is going to be based in just a few lessons. So if we take a look at f of, say, a, that's going to be 2a plus 5. If I were to take a look at f of a plus h, that's going to be 2 times a plus h plus 5. And then if I were to evaluate f of a plus h minus f of a, distribute my negatives and stuff like that, what I'm going to get is 2a plus 2, that's a 2, 2h plus 5 minus 2a minus 5. And when we simplify that, we just get 2h. So f of a plus h minus f of a is just 2h. And then the final part of this is the most important concept, is what we call our difference quotient. And that's f of a plus h minus f of a over h. And if I were to evaluate this for this problem, it would be 2h divided by h, which is just 2. Eventually, down the road, that's going to become part of our derivative when we start taking a look at limits and things like that. So that difference quotient is very important. Pretty much everything we do in this review in the next few lessons and stuff like that are stuff that you're going to have to be able to do down the road when you actually get into calculus part. Another thing that you'll have in this section that we do a little bit with here initially is some piecewise functions and some graphing. So say we have something like f of x equals, let's say it equals 2 if x is less than or equal to 1, and let's say that it's going to be x if x is greater than 1. Sketch a little axes. On 2 if x is less than 1. So here's x is 1. Let's go up to 2. That's just the equation of a horizontal line. I have a closed circle there. I have a closed circle because it's equal to. And I just have a horizontal line at 2. And then if I go beyond 1, I have an open circle here at 1. And that goes up something like that, slope of 1. Those are just sketches. We're going to start talking about continuous graphs, when you can find the derivative, when you cannot find the derivative, that kind of stuff. Sometimes piecewise functions cause people a little bit of difficulty. That's it. You should be able to do the next assignment.